P infinity is equals to A divided by R into 1 plus R to the power of D if the deferred annuity is given. P is equals to A into 1 plus R to the power of n minus 1 divided by R into 1 plus R to the power of n plus D. The amount you are going to pay for the infinite number of times you are going to call it is an perpetuity. Hello dear students, a warm welcome to one and all. My name is Vibha, Mathematics faculty at Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. In today's session, we are going to learn, and this is your last session dear students, which is session number 4 and chapter number 9, which is nothing but annuities. Now, what are the topics we are going to study under this session is nothing but you are going to have the problems on perpetuity and then deferred annuity. Ma'am, what do you mean by this perpetuity? That means the amount you are going to pay for the infinite number of times you are going to call it is an perpetuity. So here, which is an annuity which is payable forever, that is a lifetime. So that is going to be known as your infinite number of years. So is called as a perpetuity. In other words, perpetuity is an annuity whose payments continue forever. That means for the lifetime. So next you will be having the future value of the perpetuity does not exist here. Okay, because you are going to pay for the lifetime, so that the perpetuity of the future value does not exist here. So therefore the present value can be found by using the formula P infinity. That means infinity means for the infinite number of years, which is equal to A by A, or you are going to have P infinity can also be written as A divided by R, where R is nothing but the rate of interest, A is nothing but the annuity of the installment or the equal installment, and P infinity is nothing but the perpetuity for the infinite number of years. And also you are having one more formula dear students, that is P infinity is equals to A divided by R into 1 plus R to the power of D if the deferred annuity is given. So this formula also you are going to use it in the formula according to the question conditions. Now, we'll be moving on to what do you mean by the deferred annuity. So, deferred annuity is nothing but is an annuity in which a periodic payments start only after a certain specific period equivalent to a certain number of payments of a period. So, after time it will be starting, that is going to be known as the deferred annuity. That means it may be start after 10 years. It may be start at the end of the 6th year. It may be start at the end of the 3rd year. What is the difference between the 1st year to 3rd year? That is a 2-year difference. Similarly, if it start from end of the 10th year, what is the difference? Deferred you are going to have 9 years, like that. Okay. So here, if an annuity is deferred n number of years, that is the first payments will become at the end of the year as n plus 1 year. Okay, at the end of it will become what? The n plus 1 year in annuity immediate. Not in an annuity due, it is an annuity immediate. I hope you understood this one. Now, what is the formula to calculate the present value of the deferred annuity? It is given by P is equals to A into 1 plus R to the power of n minus 1 divided by R into 1 plus R to the power of n plus D, where A is nothing but the annuity or the equal installment and n is nothing but the number of years or the number of installments, and D is nothing but the deferred annuity, and P is nothing but the present value of the deferred annuity. You are going to get it. Now, we'll be moving on to solving the problem dears. What they have asked the first problem. Find the present value of a perpetuity of rupees 3000 to be received forever at 4% per annum. To be received forever means you are going to receive the annuity, right? So annuity means therefore they have given A value is nothing but rupees 3000 and 4% per annum R is equal to 4%, which can be converted as a decimal 0.04. Now, if you use the formula P infinity is equals to A divided by R, which is nothing but 3000 divided by 0.04. Now, 0.04 can be written as 1 by 25. 25 go to the numerator. 25 into 3000 is nothing but 75,000. So, this is what you are going to get, the P infinity. So, okay. So, I hope you got this one. We'll move on to the next problem, dears. What they've asked, a person enters a bed in a hospital at the cost of rupees 27,000 per annum. Now, if the interest rate is 14% per annum, how much should he provide in perpetuity? That means P infinity you need to find out. So, A, they have given it as what? 27,000, isn't it? And 14% per annum, R is equal to 14%, which is 0.14. P infinity is given by A divided by R, which is nothing but 27,000 divided by 0.14. You're going to get the answer after this calculation, which will be is equal to 1,92,857.14. You can round off that amount, which is 1,92,857. I hope you understood this one. We'll move on to the next problem. A person purchases a house for 25 lakhs with a 75 lakhs as a down payment of 25 lakhs here. The rest of the amount he loans from a bank which offers 16% per annum compound interest and has to repay the loan in 20 equal installments. In the first installment is paid at the end of the third year. So, at the end of the third year means what is a deferred annuity year? Deferred annuity is from first year to third year, it is 2 years. Find how much he has to pay each year. That means you need to find out what is A value. So, here they have given which will be P is equal to down payment he is going to pay for 25 lakhs. And then 75 lakhs minus 25 lakhs will be is equals to how much? So, present value will be is equal to 50 lakh. So, therefore, I can calculate P will be is equal to 75 lakh minus 25 lakh is equal to 50 lakh. So, P is equal to 50 lakh you are going to have, and then annuity you need to find out. So, D is equal to deferred annuity is nothing but 2 years and number of installment N is equal to 20 installment. So, what is the formula you are having? P will be is equal to A into 1 plus R to the power of N minus 1 divided by R into 1 plus R to the power of N plus D. Now, which will be is equal to A into, we don't know A, but we know it is 50 lakh. So, A as it is I am writing, this is 1 plus R is nothing but what they have given? R is 16%, therefore, R will be is equal to 16%, which can be converted into 0.16. So, therefore, writing R is equal to 0.16 to the power of N is nothing but 20 installment minus 1 divided by R is 0.16 into 1 plus R is 0.16 to the power of N is 20 installment, deferred annuity is 2. So, therefore, cross multiplying you are going to get 50 lakh into 0.16 into 1.16 to the power of 22 divided by here 1.16 to the power of 20 minus 1, which will be is equal to A, isn't it? Now, this if you calculate the numerator, you are going to get the answer is A will be is equal to 15,56,860.75625 divided by, you are going to get the denominator is 18.46075. I am considering only the 5 digit after the decimal. Now let us divide that. You are going to get the answer will be equal to 84,000 333.55. So this much he is going to pay the installment. I hope you understood this one. We'll move on to the next problem, dears. What is the present value of an annuity of rupees 6,000 payable from the end of the 11th year? From the end of the 11th year means what will be the deferred annuity? It is 10. So, and for the 15 years, that is n is equal to 15 years thereafter, the interest rate is 9% per annum. So, therefore, here we need to find out the present value of the annuity. So, A, they have given it as rupees 6,000 and deferred annuity, they have given it as 10 and N is equal to 15 installments. That is a 15 year and R is equal to 9%, which will be is equal to 0.09. Right? So, you need to find out the present value given by the formula A into 1 plus R to the power of N minus 1 divided by R into 1 plus R to the power of N plus D. Let us substitute that. So, which will be equal to 6,000 into 1 plus R is 0.09 to the power of N is 15 minus 1 divided by R is 0.09 into 1 plus 0.09 to the power of N is 15 plus 10 is deferred annuity. So, which will be is equal to 6,000 into, let us simplify further, 1.09 to the power of 15 minus 1 divided by 0.09 into 1.09 to the power of 25. So, you are going to get the answer is 15,854.8947582 divided by, you are going to get the answer in the denominator as 0.7760772594. Now, let us divide the numerator by denominator. You are getting the answer will be equal to 20,429.531. Okay. So, if you want, you can round off it to 20,430. Are you getting? So, this is what the present value. I hope you understood this problem. We'll move on to the next problem, dears. So, what was the next problem, dears? What is the present value of an perpetuity of rupees 5,000 to be received forever if the first receipt occurs at the end of the 6th year? If the first receipt occurs at the end of the 6th year means D is equal to 5. So, interest rate being 8% per annum. So, what they have given here, A is equals to 5,000 and perpetuity, that is P infinity, you need to calculate, isn't it? And then first receipt D will be is equal to 5 and R is equals to 8%, which is 0.08. What is the P infinity formula? P infinity will be is equal to A divided by R into 1 plus R to the power of D, which will be implies that 5,000 divided by R is nothing but 0.08 into 1 plus 0.08 to the power of D is 5. So, let us calculate, this will be equal to P infinity 5,000 divided by 0.08 into 1.08 to the power of 5. You are going to get the answer will be is equal to 5,000 divided by 0.11754624661. You are going to get the answer will be equal to 44,536.44. If you want, you can round off with just 44,536. I hope you understood these problems. Dear students, these are all the problems you are going to have in your NCERT exercises which have solved all the questions You can go through some of the exemplar problems in your NCERT, which is already given a solution in your textbook. I hope you enjoyed this session. In the next session, we'll be moving on to the new chapter. Thank you. Have a nice day.